Hey everyone, today we're going to talk about inheritance. In our last video in the series, we talked about the very basics of what a class is, what an instance of an object is, and how the two work with one another, and we explained how it can hold both functions and it can hold variables. So it's a little bit more advanced than a struct, which is often used as a plain old data type, which only holds variables. Now in C++, that's not necessarily true, and we will talk about that in a future video. But for intents and purposes, generally across the board, structs only hold variables, and classes hold variables, and they also hold functions. They're called member variables and member functions. In this example, we have a class we call base, and it has a couple member functions in it. And then we have another class called derived. There's a colon here, and we can see that it is publicly inheriting from the base class. And then also it has some methods inside of it. So let's see, what does this actually do? At this point here, what we're doing is we have a derived object, and it will be created and then it will go out of scope. So let's try that once. We'll build this using GCC, and then let's run it. And we can see that, so it's derived, but actually it calls the base constructor first, then its constructor, and then it is calling the destructor, and then the base destructor. Now, it is also important to note that this base destructor is virtual. You will always want to do that. And I don't believe we necessarily talked about destructors in the last video. So let's talk about those real quick. The constructor is used to initialize variables and to run any sort of initialization that you would want to do when your class or object is first created or initialized. When you have a destructor, these are things that are generally used for deinitializing things or destructing things, getting rid of them basically. So let's look at an example here. Let's put on here a pointer to a parent variable, and that's just the name of the variable. That's not a keyword by any means, but the pointer to an integer is. Now, if you don't know what pointers are, I do have a video explaining why pointers exist, when you need them, why you would use them, how to use them, and all those other good things. The extremely short crash course on that is that there's the stack and there's the free store. The stack's about a megabyte in size, and when you initialize things without stars or asterisks, things like this, it's called a pointer. When you don't use pointers, things go on to the stack. The stack's only about a megabyte in size, and it automatically is managed for you. However, if you have really, really large classes with tons and tons, hundreds of variables, or you're saving file information, things like that, you're going to have a stack overflow, which the website Stack Overflow is very helpful. A stack overflow in a program, on the other hand, is not very useful at all. So what you do is you use pointers so that you can pull memory out of your RAM, and whatever the computer's RAM is, that's basically what's available. There's also page files and things like that. We won't get into that in this video, but needless to say, there's a lot more than 1 megabyte available for you to use. And that is basically why pointers. Now, the difference with pointers is, I'll show you the wrong way to do this first. But what you do is you use the new keyword in C++, and you say that it is a new integer. And what this does is it goes out to the operating system and it says, hey, I need a spot in the free store. And some people will call it the heap. Technically that's for C, but it basically means about the same thing. It will go out to the free store and say, to the OS and say, I need whatever size an integer. In this case, it is 4 bytes. But anyway, it'll say, I need 4 bytes out of the free store, and the OS will say, here you go. You are allowed to use it, and here is the memory address. So pointers actually hold two things. They hold a memory address, and they also hold the value. And that's technically not true. Technically, they just hold the memory address, but the way we use them, they might as well hold that value as well. So we'll see a little bit of that as we move forward in here, but let's just see really quickly what this parent variable does. Now it's publicly available on the base class, so we would imagine if we created an instance of base that we could type base, and we do have access to our parent variable. Now we also could do things like this, and I'll just call this, we'll just do variable in this case. So this one's on the free store and this one's on the stack. If I set variable equal to 1, 2, 3, 4, we can see that it exists there. And let's look at object. Look at that. Parent variable and variable both exist here, but it's nowhere to be found. And the reason for that is because it inherits from our base class. So all of the goodies that base has, publicly or protected available, we haven't gotten the protection levels yet. That's an upcoming video because we don't need to muddy the waters too much on this video, which is why we're using public everywhere here. But anyway, it's publicly available, which means that the derived class can use it as well. So all of these goodies come along for the ride, which is very helpful. What it does is it allows you to utilize the DRY principle, which stands for don't repeat yourself. And we talked about that in the function video, and we also briefly touched on templates, which is some of the exciting things C++ can do. But the don't repeat yourself, just if you don't remember because you watched that video a long time ago or you haven't watched it yet, means if you are repeating the same code by copying and pasting over and over and over, there's probably a better way to do it, and that is by referencing it some other means. All right, so we can see that essentially the derived class gets everything that the base class has, and we even briefly did a crash course on variables. Now, this is not the way that you initialize variables in C++, and the way that we would do that is actually up here. So up here we would say our parent variable is a new integer, and we would also say that our variable, and if we want to set it equal to something, we can set it equal to whatever we would like, and now it will have the value that we expect it to have. So that is handy as well. So let's see here. We have two variables. We have initialized them. Also note the order. You generally want to always initialize the variables in the order that they are declared, which means that we want to do it this way, not this way. Okay, so we have covered that, and we have covered how these things are available to be used. Now let's just work with our derived object a little bit and actually see what is going on here. So if we look at our variable on our derived object, we should get 2, 3, 4, 5, 6, 7, and 8. If we run this, we can see that indeed we get 2, 3, 4, 5, 6, 7, and 8, and we didn't have a new line on here, so it calls our destructors and all of that good stuff. So why do we have this destructor? We've talked about all this pointer stuff, but we never really did conclude why we talked about destructors. And the reason for that is we asked the OS for 4 bytes of memory on the free store, but the OS technically was never told before the program ended that we were giving it back. And that's called a memory leak because, well, it's like the memory's leaking out of your computer 4 bytes at a time. Every time we call this, we're saying we need that memory, but then we never tell the OS that it's been freed or deleted, and the OS will eventually, well, I should say the computer will eventually run out of memory, and the OS will start doing things to get that memory back. And you don't want those things to happen because that usually means your program crashes. So let's delete this pointer. And by deleting this pointer, what will happen is we are telling the OS we're done using our parent variable. So it has that 4 bytes back again. And we can see here, I'm going to include a new line now. We can see here that everything builds. If we run it, everything still looks the same. And that's all great. So we have initialized memory. We're freeing it or deleting it once we're done with it. There's no memory leaks here. We remember to use virtual, and that's essentially important for something we won't necessarily muddy the waters on that now. There is another video that I made that talks about that, so you can watch that video if you want to understand those details of why we're using virtual. Okay, so obviously we also can have derived variables here, and we can use those as well. Now, if we have our base object again, the derived variables are not available here, but if we look at our object here, oops, we need to have the code in a state that IntelliSense can work with. You can see the derived variable is available on the derived object. So you can kind of almost build like these little trees that branch out and have all these extra variables the further down the line that you go. So in inheritance, we talked about our base classes, our derived classes, and how to inherit, how to initialize variables, how to get rid of them. The other thing that we probably should show really quickly is that we actually can also initialize the value that goes into this pointer as well. And this will be the fun part because it won't work actually at first because it's a pointer. If we run this, we can see that we have this fun number here. This is actually where in memory it is stored, and you can tell that because it's a hexadecimal value. It starts with the 0x, and it also has letters in here. We won't get into hexadecimal stuff too terribly much right now. If you do want to know more about that, in a different series we have What is a Byte, and it explains this hexadecimal stuff. All right, so how do we actually get the value that we're looking for? We add the little asterisk in front, which means we want to dereference it. Save this, and now if we run it, we actually have the value that we're looking for. All right, so that basically covers everything that we need to cover. Again, protection levels will be covered in another video. And oh, I did think of one more thing that I did want to cover with you. What if we want variable to be set to a variable value? Well, let's just put in here real quick an integer, and we'll call it variable as well, showing you that you can duplicate the names here, and we'll put it here. Okay, so now the base class is expecting this variable, but you can see that a little red squiggly appeared here, meaning that there's no default constructor for our base class. If we try to build it, we get those same errors. The reason for that is we need to define something in there. We have to fill this value in. So for our base class, we could put in here our value that we want, and we can see that it is fine with this. This is a solution. Or if you want to make it extremely variable, at this point you could do something like another variable, and you could pass this in. So you can see that it's quite a versatile system. And now this doesn't have a value, so now we can put in a number here, and this number is too long for an integer. We need something larger, a larger container. This should fit. And it does. There we go. So there you go. This is inheritance in a nutshell. I hope you found this video enjoyable. And if you're still here, I would really appreciate if you consider subscribing if you like the content you're seeing. It does help the video get out to a larger audience. And if you like C++ content, please like this video so I know to make more C++ stuff. All right, we look forward to seeing you in the next video.